And this one, let's say business, business laptop. This is, let's say, gaming laptop. Last one is iOS, Apple iPad. Okay. So this is the data. This is the sample data I have. Now, what I have to do is multi-level classification is happening. Where what I will do, so category, subcategory, and type is something which I have to predict. So I'll keep this as label, prediction label that we need prediction for. So the usual input will come, the brand name, price, RAM, and storage will be coming, and then based on that input, my model should basically predict this category, subcategory, and type. Now, if you look towards the hierarchy, right? So we have electronics as the category, and then we have three subcategories, right? In this case, first is mobile, second is laptop, and third is tablet. So mobile, then this is, let's say, laptop, and this is tablet. Now, mobile also have types or subcategory. So mobile can be of two types. First one is iOS, and second one is Android. Similarly, laptop is of two categories or two types. First one is business laptop, and second one is gaming laptop. Talking about tablet, so tablet may we can have, again we can have two categories, right? First one is iOS, and second one can it can have Android, right? Now you see this is a hierarchy, right? Uh, so electronics is a kind of a parent class, then mobile is a sub I mean child class of electronics, and then iOS is further child class of a mobile class. So on high level, uh, if I'll draw this line, so this is category, this is subcategory, and this is type. So everything is falling under a hierarchy, right? It's a multi-level, right? Multi-level, I told you, multi-level comes into picture when we talk about parent-child relationship, right? So, right. So if this path, if I am looking, so this is kind of a hierarchy, or we call it as multi-level. And what we are doing here, we are doing classification, right? So this is multi-level classification example, multi-level classification example. What we will be doing, so we will be providing, let's say, this data to our model. Before that, we will train our model. Then when we will be providing this new data, let's say any random data, so it should be able to predict category for that. It should be able to predict subcategory of that, and it should be able to predict type also for that particular. And these three prediction or these three parameters or columns, they fall in a hierarchy, right? So this is a hierarchy. So this is one hierarchy, another hierarchy can be this hierarchy. So every prediction will fall in some hierarchy, whatever you are seeing on the screen, right? Hence, it is known as hierarchical classification or multi-level classification. Any doubt so far? So for our multi-level classification problem in this particular scenario, these will be our features, and these three will be our labels, because we will be predicting more than one label, category, subcategory, type, and these are falling under a hierarchy, or you can say parent-child relationship. Hence, it is known as multi-level classification. Now, let me, okay. Now, let's start Python coding on this. Uh, Let me create one new Python module. So, multi-level classification and Uh, this will be our code map, which I'll copy here. And then, okay, before that, let me ask ChatGPT to quickly convert this data into a dictionary, Python dictionary. I'll just copy paste this directly then. Convert this data into Python dictionary. Okay, it has converted. So let me copy this data and let me paste that here. So read the CSV file. So this is about data loading, right? So creating a sample data set, let me write, and then let me just paste this. So I have this sample data set, which I will use to train my model. And this is a Python dictionary. So before that, I need to create this into a data frame. So df is equal to pd dot data frame, and then pandas, I have to import pandas library, right? So I have created a data frame. Now I have to define features and labels. Now, whatever examples that you guys have seen so far, right? So um, the examples that you have seen, their features or labels all were in the numerical value. So when we have numerical values, then we are good, right? For example, price, RAM, storage. These are the numerical values. And these four I will decide as my features, and these three I will decide as my labels. Now, as long as my features and labels have numerical value, I'll just directly define my features and label. But if my features have any other data type apart from, let's say, numerical value, so this is a list of string values, right? Similarly, these are also list of string types. So in those cases, what we do encoding. So encoding we usually do whenever we have categorical features and labels. Categorical features and label means when we have the values of features and labels not in numerical format, but in a string format. So define features and label in this, the first step basically will be to encode categorical features and labels. Okay. So what are categorical features? First talk about features. First feature is brand. So before deciding features and label, let's encode everything, and then later on we will decide what we have to keep as a feature, right? So first encoding needs to be done for brand, right? So let's call it as LE and brand. And to encode, I'm just creating a label encoder. So it is under sklearn pre-processing, this label encoder. So I'm just creating the instance of these label encoder. So first step is to basically create the instance of label encoder for all those value which you want to encode, basically. So this is the first column I want to encode. Second column I want to encode is LE underscore category. Okay. And label encoder. This is the second one. What is the third one? LE underscore subcategory. So I've created third instance. Fourth is LE underscore type. And this is my fourth encoder. So I have created the instance of label encoder for the respective columns that I want to encode, because these columns do not have numerical values. These columns contain string values and I want to encode them. Now, next step is that, so my data will be looking like this, right? And the these are the columns and these are the columns which have string values. Now what I will do, I will create four more columns. So one, two, on the fly I will create three and four, and I will name them as brand encoded, something like this, brand hyphen score encoding, then category hyphen score encoding, so that I can store the encoded values in those columns. Okay. Now, how will the encoded values work? I'll come to that in some time. Yeah. So before that, let's create the new columns in the existing data frame. So df brand underscore encoding I am creating, and that will be, I will be using this particular reference variable, and then there is a method known as fit transform. Okay, so what it is doing under the hood. So I have created this instance variable of the label encoder. So I'm using this. I'll be calling fit transform, and which particular column I want to transform? I want to transform this particular column, brand column. So that column I have to provide in the argument of this fit transform method. And the resulting column will be named as brand encoded, brand underscore ENC. Similarly, I will do for others also. So df uh, category encoding. I am doing for category column. Then subcategory encoded, and then type encoded. So type has encoded. Now what we have done is that we have created the encoded values. Now what does encoded value means? Now let me come to that part. For example, take brand. यहाँ पे how many brands are there? Apple 1, Samsung 2, Dell 3, and Asus 4. So we have total 4 brands. Okay. Now when I will do encoding, so total 4 brands are there. So it will assign values 0, comma 1, comma 2, comma 3 to these respective brands. Now, as long as I will tie the value 0, let's say Apple को 0, I have given 0. So यहाँ पे भी 0, 0 हो गया. Then Samsung I have given 1. Dell I have given 2. Asus I have given 3. And Apple is there. So it was already, we have assigned it as 0. So that way, we have converted the categorical values or string values into the numerical values. So this is called as encoding. So we will be doing that for every categorical column. Now category, if we'll see this category, so we have only one category, right? How many categories are there? Only one category. So here only one number is required. So I will denote by 0. So this electronics, every category mentioned here is electronics. So 0 will be assigned to these values. Now coming to subcategories. So subcategories, how many subcategories are there? 1, mobile, 2, and 3. How many subcategories are there? 3 subcategories, right? So 3 subcategories are there. So I will assign number from 0, 1, and 2. These 3 numbers I will assign to these categories. For example, let's say I have assigned 0 to mobile. So it will be 0, 0, and laptop, let's say 1, and tablet will be 2. So that's how the encoding will be done. And that's these values that I've just shown you, right? 0, 1, 0, 2, 3, 0. So that will be stored in these columns, whatever I'm creating in these lines, line number 24 to 27. So I am storing a new column with these encoded values, which are numbers. Okay. Any doubts? All good? Okay, so this was the first step, encoding categorical features and label. Now, second step is basically define the features and label. Now, define features and multi-level labels after encoding. Okay, now you have to define your features. Okay, let me. Is the font okay, or do you want me to decrease the font? That's fine. Okay, so let's define the feature x equal to df. And what will be my feature? First feature will be the encoded one, right? So I have to define these four as feature. So this price RAM in GB and storage GB, I will assign as it is because these are in number. Brand I will assign as the encoded value, brand ENC, because it was not in number, right? So my first feature will be brand encoded. Second feature will be price. Third feature will be RAM GB, and storage GB is the fourth feature. This type I will remove from feature. So this is the feature that I have defined. Now I have to define my labels. Now what labels I have to define? This is a multi-level label, right? So these three labels I'll be defining. But these three labels are in categorical format, that is in string format. So instead of that, I will be defining these encoded labels that I have just encoded the values, right? So for defining the label, I will be using the encoded values. It will be category encoded. Then second will be, okay, category spelling is wrong. Category encoded. Second will be subcategory encoded. Third will be type encoded. Okay. Okay, so this is how we have defined our features and labels in multi-level problem. And when we have these categorical features. Okay, so defining of features and labels are done. Now we'll be doing the train test split, usual step that we follow, right? X underscore train, X underscore test, Y underscore train, Y underscore test equal to train test split. Test size, okay. random state 42, ठीक है. Now we have to define the model. Now again, so this is the model that we will be defining for multi level classifier. So for multi level classifier, we will be using, let's say, decision tree. Okay, so I'll be creating a model, or instead first create a tree equal to decision tree classifier, and then I want multiple labels, so I'll be creating model now, like we have done for multi-label classification, right? The same way we'll be doing for multi-level also. So it will be multi-output classifier, and I'll pass tree here. And then I will use this model to train my data. What data I have to train? Model.fit X train and Y train. Okay, cool. Now make the prediction again. We will be predicting on the test data. So for now, just skip this. Let's focus on predicting for the new user, new data. I mean the data, new data or new input. Now let's take an example of a uh, mm, let's take that we have Samsung laptop. Iska data we have to pass, which has 16 GB RAM and 512 GB internal RAM, internal storage, GB storage. So this is the input that I am providing, right? So input may, if you'll see, इसको भी ना लैपटॉप की जगह जस्ट आई एम प्रोवाइडिंग सैमसंग ब्रांड आई एम प्रोवाइडिंग सो यहाँ पे दिस इज द इनपुट राइट टू एंड थ्री थिंग्स आर द इनपुट first is the brand that I am providing, second is the internal storage or RAM GB that I am providing here in this case, and then the storage GB. So these are my three inputs that I am providing, and I will ask my model to predict the category of that particular input that I have provided, under which category it will fall, subcategory of it, and then the type of it. So let's see what it predicts, what our model predicts here in this case. Okay. So let's create new input and pd dot data frame, and pd dot data frame में brand encoded. So okay, first is the brand I have to provide, and that I have to provide an encoded format, right? So directly let me use LE brand. So this I have created this particular reference variable I have created to do the encoding for brand, right? So I'll be using LE dot brand and then transform, and transform किसे करना है मेरे को? What is the brand name that I am providing here? Samsung. Okay. Samsung is the brand name, and this will be basically this transformation happens for the arrays. I mean this happens for array. So and I'm providing one value. So I have to provide index of 0. Like this, I have encoded my input, Samsung input. Second thing, what I am providing here is price. Okay, price I have missed here, right? We have price also. So let's use price as 1500. Let's say $1,500. Huh? So price, let me provide the price. So price will be, let's say price is $1,500. RAM is, let's say here it is 4. We have decided that we will be giving 16. Okay, 16. Storage in GB is 512. Okay, any doubts so far? So this is the input. This is a new input where the brand is Samsung. So brand is Samsung. It is a string value. So I have applied the encoding here and converted this into the encoded value. Price, RAM, and storage. These are numerical values. So this is this I have provided directly. So this is my new input. Now new prediction. So what will be the new prediction? New pred equal to model dot predict new input, right? So this prediction will happen, and now this prediction it will basically okay. Let's run this first, and let's see what's the output it will give. Okay, we are not printing anything. Let's print that. Print new pred. Okay. See, it has predicted, but it has predicted the encoded values, right? So यहाँ पे हमने encoded value बनाई थी ना. So this zero is basically the category, encoded category that it has predicted. The next zero is its encoded subcategory it has predicted. This is encoded subcategory. And then next one, what it is predicting is the encoded type. Now we don't want this, we don't want to display this output as an encoded value. So we have to reverse transform these encoded values to its original value, right? So next step will be to convert uh, encoded predictions back to readable values. Let me write. Okay. For that, what I will do? For that, I will basically uh, let me create a data frame of values. So new prediction and then data frame I am creating and pd dot data frame I am doing. And here, let's convert back. So first thing that I have to convert back, I want back is category. So category will be, I will use the encoder reference variable or encoder object. So le cat category kya tha? Le. Okay, le cat was there, right? Le cat dot inverse transform is the function I'll use. So this is inverse transform is to decode the values, and transform that we have used previously was to encode the values. So I am just decoding the values now, right? Okay, le cat dot inverse transform. What I want to transform? So I want to transform new predict pred ये वाला whatever this one got predicted, right, इसमें, and this will be in the form of 2D matrix. So I will be basically, because output में देखो, this is a 2D matrix it was giving, right? So these are the rows. So 0, comma 0, this is 0, comma 0, this is 0, comma 1, this will be 0, comma 2. So how will I extract the value? New pred. This will be, first one will be 0, 0. I hope there are no syntax mistakes in this. Okay, looking good. Next is subcategory I want to do. So subcategory may lay sub le underscore sub dot inverse transform I am doing, and last one is type. This is how I do. So let's print this value. So new prediction df is equal to instead of this, let me write something more meaningful. Predicted category, comma subcategory, comma type of the input device is this. So let's run this. So it has predicted. So it has predicted category as electronics. So every category is electronics, and it has predicted that the input that you have given belongs to laptop, and it's a business laptop. How it was able to predict on this? It was able to predict this data because my model has trained itself on this data that I have provided it. It has done encoding and decoding internally when it was applying the logic. And finally, when you have provided the model a new input where you have just, provided the brand, price, RAM, and storage, it was able to predict that the device belongs to electronics category, laptop subcategory, and business type. Now, this prediction you can see, uh, you know, Three labels are there in this prediction, and these three labels are basically into parent child relationship or hierarchical relationship. So hence this is known as multi-level classification problem or multi-level classification example. Any doubt so far? Anirudh, Sarthak, Deepak, anything from your side which you want to add? So this is one of the most complex problem out of all classification problem. Hence, I thought I will take it separately on a fresh day. So is this clear, Deepansh? Any doubt you have? Anything which is not clear? And again, I'm telling you again and again, you have to do hands-on on your own. So you might be able to get whatever I'm explaining, but if you'll not do hands-on, this particular concept will be in your mind for a couple of days and then it will be gone. So the best way to persist this concept for longer time in your mental memory is to basically do hands-on on your own. Okay, create code map like this. So this is just an example. You can create more detailed code map and then start implementing these steps one by one. And that way you will be able to get the concepts. So this was the concept of multi-level classification. Cool. Now, next thing that we will be going to see is performance evaluation matrix. So what performance evaluation metrics are there for classification problems? Okay. So performance evaluation metrics. So there are few terms that are used in performance evaluation metrics when we talk about classification problem. First term is confusion matrix. Then we have something known as true positive, which is known as TP. Then we have true negative, which is known as TN. Then we have false positive, which is known as FP. Then we have false negative, which is known as FN. Okay. So these are the basic terms. And then I would say these are the basic terms. So basic terms में ये सारा it will go inside these basic terms. And then we have error based metrics, and then we have non-error based or success based. Let me write success, and these are non-error based metrics. Okay. Now error based metrics में what all things we have? We have error rate, then we have false positive rate, then we have false negative rate. So these are common error-based metrics in classification problem. Non-error-based or success-based metrics are accuracy and precision. Then we have recall. This is also known as sensitivity. And then we have something known as specificity. And finally, we have F1 score. Now, out of all these, matrices, accuracy and okay, where is F1 score? Okay, I think it is not saved. So F1 score. Okay, so out of all these matrices, Accuracy and F1 score are more commonly used. And these are the matrices, these are the basically these are the values which you calculate. So let's see what are these terms one by one. Okay. So for that, okay, this is a small table that I have created. Cool. Now talking about these tables, let's say this is actual class. Okay. First of all, this is a churn problem that I have considered in this example. Churn problem means whether customer is churned or customer is not churned. Now, positive values, whenever we are deciding positive values, so we denote positive values as the class of interest. What do I mean is that my class of interest is churn here. That means my interest is to look for churn, right? If my interest is to calculate or look for churn, so मैं churn को I will make it as a positive class. So positive के लिए I will denote it with 1, and not churn के लिए not churn I will decide it as 0. Let's say in other scenario, in other situation, let's say my interest class or my interest is to look for non churn or not churn. So उस केस में I would have made not churn as 1 and churn as 0. So just remember that you have to look forward to your interest in a particular use case, and as per that interest, the positive and negative you basically denote to your class of interest. So ये we will be telling this churn अगर 1 है तो this will be our positive class, right? And non churn not churn यहाँ पे हमारा it will be denoted as a negative class. Okay. So this is how we basically decide on selecting the positive and negative class of interest. So यहाँ पे we have selected churn as the positive class of interest and not churn is negative. Okay. Now seeing this particular table, this is my actual class. Actual class means actual output. मेरा actual output है. This is my actual output. And this is my predicted output. This is the predicted output. That means I have given this data set to my model. This is the data set that I have initially given to my model. And then for each data set, I have also calculated the predicted values that my model is predicting, so that I can decide whether my model is performing well or not. For example, मैंने data जो दिया है, whatever data that I have given, वहाँ पे churn है, and then it is predicting churn, which is correct, right? So वहाँ पे we will see that, and we'll see, okay, actual was churn and prediction was churn. So prediction also it was churn, right? So it will be considered as true positive. मतलब churn is my area of interest, class of interest. So वो true positive हो जाएगा. If my actual output is 1, but in the predicted output it is showing as 0. So उस केस में it is known as false negative. Okay, इसको let me simplify more. यहाँ पे for predicted class, let's write down in each column. So 1 is positive for me and 0 is negative for me, right? मतलब churn is positive for me, not churn is negative for me. So यहाँ पे this is positive. I am just writing down for the predicted class. Similarly, not churn है यहाँ पे अगर, so it is negative. Okay. And यहाँ पे भी let's say ये positive हो गया, and यहाँ पे this is negative. मैंने why I'm writing this is because I want to explain you the concept of true positive, false negative, true negative, and false positive. सो प्रेडिक्टेड, लेट्स टेक दिस फर्स्ट केस यहाँ पे. इन दिस केस predicted class is showing positive value, right? So actual में is it positive? Value is positive. Yes, it is positive. So this is true positive. This true positive, true negative, this I am writing with respect to predicted output, with respect to predicted output. ठीक है. Now let's consider this third case. So third case में my predicted output is negative, right? सो नेगेटिव है बट इन एक्चुअल इट इज पॉजिटिव, राइट? सो ये नेगेटिव क्या हुआ? ये नेगेटिव, इज दिस ए ट्रू नेगेटिव? बिकॉज इट इज नॉट मैचिंग टू द एक्चुअल क्लास. सो दैट इज वाई इट बिकेम फॉल्स नेगेटिव. नेगेटिव इज कमिंग but it is a false negative because it is not matching with the actual class. So that's what I'm telling. True positive, false negative, everything we are writing with respect to predicted output. ठीक है, इसको हम ये नहीं बोलेंगे false positive, यहाँ पे positive है तो we are basically considering the predicted class, and with respect to the predicted output we are deciding whether it's a false or true. ठीक है. Now let's see the case number 5. यहाँ पे predicted output is positive but यहाँ पे actual class में is it matching, is it positive? No. तो यहाँ पे ये it becomes false positive. ठीक है, this becomes false positive. Now case number 6, if we will see case number 6 में the predicted class is showing negative and actual class में भी negative है, मतलब actual output में भी negative है. So in this case this becomes true negative. Okay, so this is how we decide true positive, false negative, false positive, true negative. Okay, and this you don't have to do on your own. Your model, you have we have Python methods which will eventually calculate these true positive, false negative, false positive, and true negative. But in order to understand, you should be knowing कि ये how do we basically come up with these concepts. So any doubts so far on understanding what is true positive, false negative, false positive, and true negative? Any doubts? No? Okay. All clear, Sarthak? Clear?
Yeah, all clear. Am I audible?
Yes. Okay. Okay, let's take 10 minutes break, then we will continue. So we will continue from here, true positive. We'll calculate total number of true positive, false negative, everything, and then we will learn how do we calculate these things, right? So let me start timer and let's meet after 10 minutes. Hey everyone, welcome back. Okay. Okay, so let's calculate the true positive in the whole data set now. So total true positives are, 1 second. Yeah, so total true positives in this data set are 1, 2, 3, just 3. Okay, so these are 3. Total number of false negative, 1, 2. Total number of false positive are again 2. And total number of true negatives are 1, 2, 3. 3, 3, 6, 7, 8, 9, 10. Okay, total 10. Yeah, this is the summation of these different terms. Now, let's see how do we basically calculate different types of error terms and non-error terms. Let me write down here itself. Okay, so ये तो हो गया. Okay, so error rate. First of all, error rate is known as false positive plus false negative divided by total. So false positive plus false negative divided by total. So in this case, error rate क्या होगा? Error rate will be, okay, let me write down here itself. False positive plus false negative divided by total. So this will be, in this case, it will be false positive is 2, false negative is 2. So 2 plus 2 divided by 10, 4 by 10. So it will be 0.4. ठीक है, this is the error rate. Second is false positive rate. False positive rate. So false positive rate is known as how many false positive we have, and divided by true negative and false positive. True negative and false positive. So here it will be false positive are 2 divided by true negative plus false positive. True negative are 3 plus false positive are 2. So it will be 5. 2 by 5, again it will be 0.4. Next is false negative rate. False negative rate. It is calculated by dividing false negative and then in denominator false negative plus true positive. False negative plus true positive. So ये हो गया false negative is 2 divided by false negative plus true positive. False negative is 2 plus true positive 5, again 5. So it will be again 0.4. So these are error-based matrices that we are calculating here. Now coming to the non-error based matrices. So non-error based matrix में first matrix is accuracy. Accuracy is calculated as true positive plus true negative divided by total. So यहाँ पे true positive is 3, true negative is 3, so this will be 6 divided by 10, it will be 0.6. Okay. Next is precision. Precision is calculated as true positive divided by true positive plus false positive. तो ये हो गया ट्रू पॉजिटिव इज 3 डिवाइडेड बाई ट्रू पॉजिटिव 3 प्लस फॉल्स पॉजिटिव 2, तो 3 डिवाइडेड बाई 5 which is again 0.6, right? Okay. Next is recall. So recall is calculated as true positive divided by true positive plus false negative, which will come as 3 divided by 3 plus 2, 5. So it will be again 0.6. And then we have something known as F1 score, a very important matrix. It is calculated as 2 into uh, 2 into, okay, let's write it down. ऐसे करके लिखते हैं 2 into precision into recall divided by precision plus recall, like this. So इसको if we will calculate in this case, it will be 2 into 0.6 into 0.6. ठीक है, ये तो ऊपर this is the numerator and divided by precision plus recall. So ये हो गया 0.6 plus 0.6, 1.2. So when we'll do that 1.2 again, it will come as 0.6. So these are the matrices that I have calculated from this particular example. Now, usually, in general, most common way is basically to calculate this. I mean, to focus on F1 score and accuracy, these two things. Because in F1 score, precision and recall is already considered. And it's kind of a, what do you say? Basically a harmonic mean of precision and recall. So it balance precision and recall. So accuracy and F1 score is one of the most commonly used matrices to define the models performance. Okay, and error rate also is something which you can focus on. Now, what's the importance of using, calculating these, and then how to use that? If you remember, so यहाँ पे we have calculated in regression problem, we have calculated MAE, MSE, RMSE, R square, right? And then there are excellent, good, and poor ranges. And then this table is a universal table which you can basically use to determine whether your model is underfitting, overfitting, or good fit. Because in both training and test data set, we will be calculating these matrices which we are, discussing. And then based on this table, so your model will fall under any of these categories, right? So यहाँ पे भी in classification, so these are error-based matrices, right? So for error-based matrices, let me talk about the range. So error-based matrix may, let's say this is 5, this is 15, and I'm talking about percentage here, right? So यहाँ पे this is the, actual value that is coming, and in order to find the percentage, you have to multiply it with 100. Similarly, यहाँ पे भी you have to multiply every value that you are getting with 100 to get the percentage. So this range, ये range है, right? So anything less than 5 is an excellent range. Anything less than 15 and between 5 and 15, it is an acceptable range. And anything above 15 is not acceptable. So this range is not acceptable range, and this is an acceptable range. This I am talking about error matrices. What are the error matrices in my classification problem? Error rate, false positive rate, false negative rate, percentage. So this is the table that will basically, help you in determining whether your model is a good fit or not good fit. If it is in acceptable range, yeah, you can consider it as a good fit. If it is not in the acceptable range, then you can consider it as not a good fit. Now, this range is something which we most commonly use, and it can differ. This range can differ from project to project, not project to project, as in it can differ from use case to use case. But yeah, as a standard to keep a baseline of the rule for the acceptable and non-acceptable range, you can consider this range as the benchmark. Now, talking about the success matrices. So for success and for error matrices, see, error term is there, right? So less the error, better it will be, right? So that is why when the value is less, it is better, right? It is acceptable. That is why anything less than 5 is considered as excellent range, because it's a error matrix. And for error, less the error is, better your model is. Correct. Now talking about the non-error or success matrices. So let's say this is 70, and I'm talking about percentage here, and this is 90. So for anything greater than 90 is considered as a excellent range. Between 70 and 70 and 90, it is acceptable good range. So overall, this particular range, anything greater than 70 is acceptable range, and anything less than 70 is not acceptable. So this is basically, this particular range is not acceptable. Not acceptable. Okay. So this is how you basically define your acceptable and non-acceptable ranges for error and non-error matrices in classification problem. Okay, so this is the range. Now, in regression problem, we have different ranges, right? So this was the range. And in classification, whatever range that I have shown you, that is the range. Now, when we calculate the performance of any, what you say, any model, right? Whether that's a classification problem, whether that's a regression problem. So how do we do that? First of all, okay, the first step क्या करते हैं हम? We will first of all decide the matrix. Decide the matrix to focus on. ठीक है? अभी जैसे रिग्रेशन की प्रॉब्लम है, सो फॉर रिग्रेशन वी विल लेट्स से कंसिडर RMSE एंड R स्क्वायर. अब रिग्रेशन एंड लेट्स से क्लासिफिकेशन की प्रॉब्लम है, तो क्लासिफिकेशन में लेट्स से वी हैव डिसाइडेड टू focus on accuracy and F1 score. Now I have decided my metrics that I have to focus on, correct? Now these matrices comes with some range that I have shown you, right? Acceptable range and non-acceptable range, right? So keep in mind the acceptable and non-acceptable ranges for these matrices. Okay, done. Now second step is to uh, calculate above matrices for, first of all, for training data set, then calculate the same matrices for test data set, right? This is my second step. Okay. Now, how do you decide whether your now basically you have to decide where your model lies. Now decide whether your model is good fit, overfit, or underfit. Overfitting or underfitting. How do you decide this? How do you decide this particular thing? From this table, right? This is the table. How you basically decide whether your model is a good fit, overfit, or underfit. Now, before this step, we have seen the basic Python flow, right? So basic Python flow, whatever I have shown you till now, basic Python flow. So we have seen the basic Python flow before this step. We haven't came to this step because we don't want to evaluate our model. We directly did the prediction, irrespective of how our model is performing. Now, after basic Python flow that we have seen for regression and different classification problem, this is the next step that we have to focus on in order to calculate the performance of my model. And these are the steps, right? First of all, decide the metrics in which you want to focus. Then keep in mind the acceptable and non-acceptable range. Then calculate above matrices for training data set and test data set, because we were splitting the training and test data set, right? In our Python problem when we were seeing the basic flow. And then once you calculate it, basically, then you decide whether your model is good fit, overfitting, or underfitting. So how do you do that? How do you decide that? You decide this with this table, right? If both training and test ka jo metrics, whatever we have calculated, are in acceptable range, and the gap percent is less than 10, it is good and a good fit. If it is more than 10, it is borderline fit. If both training and test का जो matrices का range है, it is in poor range, then gap doesn't matter. If it is poor range, then that means it is underfitting. Training का if it is in acceptable range, test का if it is in poor range, then we will check the gap also, gap percent. If it is less than 10, it is borderline overfitting, can be accepted. If it is more than 10, then it is a overfitting for sure. And अगर ट्रेनिंग का if it is in poor range, test का it is in acceptable range, then it's a unusual example, and I mean it doesn't happen. So you have to basically check the authenticity of your data set in that case. So as fourth step, once the model is decided, कि if my model is good fit, I am good to lock my model. So my model is production ready. I will go ahead with my model because it's a good fit. If it is overfitting, so यहाँ पे fourth step is take necessary steps if the model is overfitting or underfitting. So if the model is overfitting, what steps generally you take? If it is overfitting, then in that case, you may have less samples. So add more samples in your data. Adding more samples means adding more rows in your data. And you remove the irrelevant feature. So there might be some feature which may not be relevant, or it is giving the false impression on the model training. So you have to decide, you have to brainstorm, and then you have to analyze and remove the irrelevant feature. So this is the step. These are the basic steps that you will take in order to remove the overfitting. For underfitting, if your model is underfitting, then you have to increase the model complexity. So increasing model complexity means if you are using linear regression model, then you will basically switch and use a complex model like random tree, decision tree. And second step can be you can go ahead and add more informative feature in your data set. So your feature might not be that informative, so you have to brainstorm, you have to think through it, and you have to add more informative features. So this is how you decide your uh, I mean, this is how you will evaluate your model performance. It is a very complex and very tricky thing. That is why I have, lead the foundation step by step, brick by brick. I don't want to confuse you, by giving all the examples and considering model evaluation steps in the starting itself. I just want to show you first the basic Python flow. How does it work? And then I, want to show you how do we go ahead and calculate the model performance and how do we evaluate our model. So these are the steps on which how we evaluate our model. Any doubts? Any suggestion? I think I have little bit unstable internet connection. So if I'm not able to respond to your voice, I may not be able to hear it. So you can ping in the chat also so that I don't miss anyone. ये वाला let me copy paste this in the chat. Copy हुआ है क्या ये? I don't know whether it is copied or not. One second. Okay, I've just copy pasted this explanation, explanation snapshot so that you can relate it later on when you are revising these concepts. So, any doubt, Anirudh? Anything from your side? Sarthak, Dipansh, Deepak, anything from your side?
No, it's fine. I was having one query related to the old
Okay.
example which you were saying.
Uh,
That was we defined four inputs for that Python program.
okay.
Suppose if we provide only three inputs, so this program will work or give some error.
Yeah, I mean, see, it will work. So it is up to you, right?
Mm-hmm.
Means, let's say you have given some data set, right? And then it is up to you whatever you want to decide on features and non-features.
Mm-hmm.
The best possible way is to define these four things as feature, right? Best possible
Mm-hmm.
way, because you have to uh, consider the brand also, because Samsung, if we'll talk about Asus brand, right? So Asus में Asus brand और Dell के brand में we don't have the telephone basically sorry tablet जो होती है ना tablet it doesn't come.
Mm-hmm.
So that's where brand is something which we have to take under consideration. And again, price is a very important thing because laptop price will differ from mobile price. So that differentiation is there. And that differentiation is an important factor on which your model should understand that price differentiation. And then RAM and storage, all these things are, considered because these are important things on which your model will train. you
Mm-hmm.
can you can decide to just select, let's say, two features also in that, but in that case your model is missing something. मतलब इसका मतलब ये हुआ कि let's say you have an exam, right? So
Mm-hmm.
you have an exam, you have a maths exam, and maths exam has 20 topics, and you have given books where you have just 10 topics. So your model will learn from that 10 topics, but remaining 10 topics are missed. So it may not be able to perform well in the exam. मतलब कि when you will eventually calculate the performance of your model,
Mm-hmm.
it may fail there. It may, underfit in that case. So that is why we decide on selecting the best features, best possible features at the starting itself. And brand, price, RAM, storage, all are relevant features that we have selected.
Mm-hmm.
So yeah, so that depends on how you are approaching your problem.
Mm. Okay, okay, okay. For example, we have like in this example, we decided to put four as input, but at the time of prediction, if we are passing only three inputs, so will this model work or?
If we are providing three input, this will
Mm-hmm.
not work because see, we have decided the feature, right? तो
Mm-hmm.
फीचर के लिए वी शुड बी रिक्वायरिंग फोर इनपुट्स ओनली. अगर मैं
Okay.
यहाँ पे इफ आई विल रिमूव दिस, पहले तो अपना
Mm-hmm.
ये एरर दे देगा व्हेन आई ट्राई टू रन दिस ना.
Mm-hmm.
Let's try to run it. Let's see if it works or not. It will, according to me, it should not work, but let's see it. Yeah,
Mm-hmm.
because we have decided our features, right? So feature का मतलब होता है input.
Mm-hmm.
So when we are giving the data for the new or unseen, data, then in that case, model is expecting that whatever features you have decided to train your model, it will be basically expecting all those features to be passed.
Yep. Okay. Got it.
Okay, cool. Okay, so this is about regression and classification. तो अभी का what we have done so far. Uh, hello. डिस्कनेक्ट हो गया.
No, no, you are audible.
नहीं नहीं you are audible.
मुझे लगा डिस्कनेक्ट हो गया. एकदम से शांति हो गई. ओके, ठीक है. सो अभी व्हाट वी हैव डन, सो व्हाट वी हैव लर्न सो फार इन मशीन लर्निंग में वी हैव लुक्ड ऑन सुपरवाइज्ड एमएल. ठीक है, सुपरवाइज्ड एमएल में व्हाट थिंग्स वी हैव सीन, two things we have seen. First is the task type regression, and second is classification. ठीक है, regression में we have seen uh, simple linear regression, and then multiple linear regression. Classification में we have seen binary, multi-class, multi-level, and multi-label. So binary, B, multi-class, multi-label, and multi-level. ठीक है, दैट्स व्हाट वी हैव सीन. ये जो हमने देखा अभी तक ये सारे एग्जांपल, वी हैव सीन जस्ट द पाइथन बेसिक वर्कफ्लो. बेसिक वर्कफ्लो मींस वी हैवंट कंसिडर्ड मॉडल, वी हैवंट कंसिडर इवेल्युएटिंग मॉडल्स परफॉर्मेंस. करेक्ट, दैट्स व्हाट वी हैव सीन. सो अभी तक मशीन लर्निंग में व्हाट वी हैव लर्न, this is the thing that we have learned so far. Now next lecture, what I will do, I will pick any either regression problem or classification problem, and on top of basic workflow, so basic जो Python का basic workflow है, I will pick any basic workflow that I have shown you, basic workflow, and on top of it, I will implement the concept of evaluating the model. Evaluate the model. So next class में I will implement this part either for a classification problem or regression problem, anyone I can pick, and then it will show you the complete pipeline, ML pipeline, on how do you basically approach for a machine learning problem. So when you evaluate the model and take necessary steps to fine tune your model is basically what matters, right? So in next class, I will try to build the whole ML pipeline. And then once we'll do that, then we will basically start unsupervised learning. So we will start unsupervised learning. Okay, so this is about today's session. So again, I'm just suggesting you please revise these concepts and try to do hands-on on your own. Otherwise, you may understand everything in the class for sure, but if you know after 2 or 3 days, if you will not practice, it will go off from your mind. So try to do some hands-on. Cool. So let's meet in the next class next weekend then. Thank you, everyone.